Hello everyone. So today we're going to get into an example of how to run an independent sample t-test and a dependent sample, often known as the paired sample t-test in Excel. Both of these are under the data tab with data analysis, but here I have an example already put together, fictitious data, nothing in particular, but with it I've posted a general what the researcher is interested in with some data to go along. And at the bottom you might notice the t-test formula itself. Based on the formula, we could go in and identify the mean, the sample size, the variance for both sample 1 and sample 2 and do this. But given Excel's add-in tool pack and extension, it does it for us, so it's a lot easier. Keep in mind, in subscript 1 is just sample size of the first one, group 1, and this is the variance for group 1 as well. That's all it's referring to there. So we could do this fairly easy by just highlighting those. We see that even the average is 6.411. There's 17 of those observations. So we have a lot of information there. We would just have to calculate then the variance, and we could do the t-test ourselves. But with that, let's go through how to do it in Excel. So to get your mindset into this example, we're interested in if there is a difference in crime occurrence around two different types of facilities. These are often described as crime generators or tractors, churches, and liquor stores, so two distinct facility types. Oftentimes churches are argued to have a protective effect, less crime around them, while liquor stores on the other hand have more crime based on the type of transactions that occur there. So based on zoning parameters for this city, the two facilities cannot be in close proximity to one another. So with that, there's no overlap in space, no shared spaces, so they're mutually exclusive in where they are. So we're interested, is there a difference between the groups and the mean number of crimes occurring? So we have churches and liquor stores from a fictitious city with counts of each one. So each observation here reflects a different church and a different liquor store. I kept our overall sample size of each the same, so both of them have 17. So we'll get into now when you go into data analysis, you have three different options when it comes to a t-test. You have the paired two sample of means. This is your dependent paired sample t-test. Not important for us here. Then you also have two other types of t-tests. You have equal variances and unequal variances. One of the underlying assumptions for a t-test is equal variances. And for this video, not going to get into the discrepancies and differences between equal variance and unequal when we're calculating a t-test. For our purposes here, since the variances are not going to be drastically different, when I say drastically, about 2 times each other, we're going to stick to equal variance for now. If you're interested in understanding when it's appropriate to use the unequal to equal, even the f-test, please reach out to me or just Google when it's appropriate to use the unequal one. There's other tutorial videos that explain that in greater detail. That's not the purpose of this one. Alright, so now we're going to go ahead and use the two sample assuming equal variances one. Hit OK. Pop that up. So here the input's asking for your variable one range. So here going to highlight the church column, including the label itself. Same for the liquor stores. Here the hypothesized mean difference, null hypothesis equals 0. We do have labels so that we have church and liquor store at the top. Our alpha is our level of risk that we set for this. I'll show you a comparison to the t-table afterwards to see where it's pulling that value from. And then the output range, we're just going to specify where we want the output for this calculation. Once you do that, you can hit OK. And let me just bring this over a little bit so it's a little easier to see. Alright, so now let's make sense of this information. If you remember from the beginning when I just highlighted the values under church, it gives us a 6.411 as our mean, our average number of crimes occurring around a church. This is what we're seeing again here. With that, we also see liquor stores. They had a higher average, so they had about 9 around each liquor store. We see our variances are very similar but not equal. Observations, there's 17 of each. So if you remember, our degrees of freedom with that is the sample sizes of group 1 and group 2 added together, subtract 2, so that gives us 32. So our obtained t-statistic, our t-value, it's non-directional. So we have negative 1.923. So keep in mind, since we have non-directional, we're interested in a two-tailed distribution. So here we see our critical value is 2.03. It's less than our critical value, our obtained value. Even though it's negative, they're viewed as almost an absolute, so it can go either way. So with that, we fail to reject the null hypothesis, and we cannot say that the mean number of crimes around either facility types differ. If we did go with a one-tailed directional hypothesis, and it could easily make the case of liquor stores would have more crime than churches. We did not do that because I wanted to show an example of a two-tailed distribution and why it's important to understand directionality for that. So remember the critical value here of a two-tail, we set the alpha level to 0.05, degrees of freedom was 32. So if we go over to a t-table now, just so you can understand where this comes from, so we had a two-tail, alpha value of 0.05, and we had degrees of freedom of 32. So we'll go ahead and round down to be conservative here to where we have 2.042 as our t critical value. So again, we can see where this value came from. Even if we were to do it by hand and have to look up the t critical value, we still see that our obtained t value is less than our critical value, so we failed to reject the null hypothesis here. So again, to conclude, there was not a significant difference in the mean number of crimes occurring around the two facility types. So the groups, there was not a significant difference. We see that based on our two-tail critical value compared to our obtained value. We see that our obtained t-stat there is less than our critical value. Keep in mind we did a non-directional here on purpose to show why this matters and important to understand directionality and how that changes a one-tail to two-tail. All right, let's move on now to our t-test with dependent, or a sample pair test. Here, similar to the prior one, we have the formula down here, the sum of differences, the differences squared. Again, we could calculate all this in Excel through just basic formulas, basic arithmetic with add, subtraction, and the squaring. And we could do this ourselves. But Excel makes it easier on us, and we're interested in understanding if there's a difference. In our example, before and after. So oftentimes when you see a paired sample t-test, it's a pre-post, before-after type setup. The example here, we see that there's a growing trend in the usage of R for data analysis. We are interested in whether a R workshop decreases the amount of times students have to search the internet for how-to per assignment. So here we see a directionality, and we're assuming based on that then that there's going to be a decrease post-workshop in the number of times a student has to Google or search for how to blank in R per assignment. So that's what we want to test to see if there is a significant difference in the mean pre-post, before and after, with a paired sample t-test. So to do that, again, we can see here we have, if we do a count, 10 different people. We have their before, how many times they searched, and then we also have their after. So it's paired, time 1, time 2. For this example, we're still going to use an alpha of 0.05. Remember, for degrees of freedom, when it comes to a paired sample t-test, it's still in the denominator of the formula. It's n minus 1, so 10 minus 1 is 9. So we have 9 degrees of freedom. We can still look that up on the t-distribution table, the t-table itself. So if we assume then that we're going to have directionality, so it's a one tail, and then it's 0.05 with 9. So let's look at that. One tail, alpha is set to 0.05, and we have 9. Here we can see our critical value will be 1.833. And I'm showing this ahead of time because when we run it, we'll get the same answer there. All right, so let's come back into here. Again, we're going to go into Data tab, Data Analysis, excuse me. And this time we're going to use the t-test paired to sample for means. And this one I already had highlighted, it looks like, so let me just exit out all of that again. All right, so again, similar to the independent sample t-test, we're going to input our variables themselves. So variable 1 is the before workshop. The variable 2 is our time 2 after the workshop. And again, we assume that there's going to be a decrease, or a null hypothesis is there's no difference, equality there. So what we're trying to find with our research hypothesis then is the mean number of times how to a search per assignment decreases post-workshop. So we want to understand the pre-post and if there's a statistically significant difference in means at time 2 compared to time 1. So here, I'm going to set that to 0 again. We do have labels and output range. We're just going to select a cell off to the side to keep it on the same page. Hit OK, it's running for us. And again, we're going to pull this up. And since we knew it was going to be one tail, and since we just went over the t-table, we can jump down and look at the critical value of 1.833. We see it's the same. That's a good sign that it ran correctly in terms of calculating the degrees of freedom. Easy way to double check to make sure you grabbed all the data. 9 degrees of freedom, we have 10, so n minus 1 there. And again, we see that our means are up here before and after, so you see a decline. You even see a decline in the variance. And with that, and not surprisingly with a dependent sample t-test, when you're looking at time 1, time 2, time 1 is very predictive of time 2, and you see a high correlation value here, which isn't surprising. But we do see that our t-statistic here, our obtained value, is greater than our one-tail critical value. So we see here that our obtained is greater than our critical value. So we can reject our null hypothesis. And with that, that's at the 0.05 level. So the mean number of times how to a search per assignment is significantly statistically significantly lower at time 2 compared to time 1. So if there's any questions surrounding that, please feel free to reach out. I can provide another example and go over it a bit more if you want to see another data set. For those who are sticking around, there is another way to run a t-test in Excel. If you don't want to go through the data analysis part, you have to pay closer attention, but there is a t-test function within. So if you do t.t-test, it gives you the items that it wants to have input into array 1, array 2, so that's group 1, group 2, number of tails, and the type of t-test it's running. So with the data in front of us, we're going to do the same part without the labels. So array 1 is the before the workshop, comma, after workshop. Number of tails, for us, we did a directional one, so we have a 1 tail. And then the type of t-test, it wants you to put in 1, 2, or 3 for paired, equal variance, or unequal variance. Ours is paired here, so we can close that off, hit enter. What we see here is our significance value. So we get the same significance value here as we did for the 1 tail up here. The E05 at the top means how many zeros are over here, so we know it is a significant difference in the mean pre-post or before or after. It doesn't give us all the other information within the t-stat calculated versus the critical value, but it does provide us if it's a significant difference in the mean. So that's another way to do it if you want a quick understanding if there is a significant difference of that. If there's any questions, please, like I said, reach out, let me know. Cheers.